Hi, welcome to my video on the graphs of sine and cosine theta, part 1. And this graph, or graphs, are going to be in terms of degrees. We have 3 circles here, and each of these circles is what I call a unit circle. And the radius of a unit circle, unit means 1, so the radius is 1. That means that this point here, x is 1, y is 0. This point here, x is 0, y is 1. This point here, x is negative 1, y is 0. And this one, x is 0 right here, and y is negative 1. And let's look at what we call, in terms of, we're going to look at the reference angle of 30 for each of these points. This point, this one, and this one. So if we have a reference angle of 30 right here, that means this angle is 60 because it's 30, 60, 90 right triangle. Opposite 30 is a half. Opposite 60 is root 3 over 2. So that means this ordered pair here, x is root 3 over 2, and the y is a half. So if we take this point and go right across here, that means that this point should have, this is a reference angle of 30, this is a 60, so opposite 30 is a half, opposite 60 is root 3 over 2, but in this quadrant the x is negative. So that means that these ordered pairs here, x is negative root 3 over 2, and the y is 1/2. And again, the reference angle here is 30, right there. That means that this is a 60, and the x is the same. The x in this quadrant, this distance here is negative root 3 over 2, so in this quadrant is negative root 3 over 2, but the y is going down, so the y is negative. So x is negative root 3 over 2, and the y is negative 1/2. And in the fourth quadrant, this reference angle is 30, this is a 60, and the x is root 3 over 2, and the y is a negative 1/2. So the coordinates of this point, the x is root 3 over 2, and the y is negative 1/2. So notice when the reference angle is 30, all the x coordinates are the same value except plus and minus. X is positive on this side, notice, and x is negative on this side. And the y's are the same values, but the y's above are pluses, and the y's down below, the x-axis, are negatives. And notice that this rotation right here is a 30-degree rotation. And this one, that's a 30, so 180 minus 30, so that's a 150 rotation from here to here. And since that's a reference angle of 30, that's 180 as far as here, plus 30, so that's a rotation of 210. And this rotation is 30 here, so it's 360 minus the 30, and it gives 330 degrees. So that's when the reference angle is 30, notice. Well, what about when and let's do this one. I keep putting these in because they're so important when we're doing the trig to remember these ordered pairs. You have to memorize, this is x is 1, y is 0, x is 0, y is 1, x is negative 1, y is 0, x is 0, y is negative 1, and this time we're going to use a reference angle of 45 degrees. So 45, this angle is 45. This reference angle is 45, so this angle is 45. Notice when the reference angle is 45, you have two angles that are 45s. That means you have two sides that are equal. So that means In a 45 right triangle, the opposite is root 2 over 2 and root 2 over 2. So it's root 2 over 2, root 2 over 2. They're the same. This is a 45, so this one is root 2 over 2. This one is root 2 over 2, but it's negative because the x is going over. So the x is negative root 2 over 2, and the y is positive. And this one right here, again, the x is negative root 2 over 2, but the y is going down, so that's a negative root 2 over 2. And in this quadrant, 45, this is x is root 2 over 2, and the y is negative root 2 over 2 because its y is going down. Notice in a 45 right triangle, all the angles in the triangles are 45s, and notice that every number here is root 2 over 2, but this is x positive, this is x positive. The y is positive going up, the y is negative going down. The x is negative over here, and the y is positive going up. And in this quadrant, the x is negative and the y is negative, but they're the same. And the rotation here is 45 degrees. And this one is 180 minus 45. This is 135 degrees. This one is 180 plus 45, so it's 225. And this one here is 360 minus 45, which is 315 degrees. Just reviewing what was done in the previous videos. So what about if you have a reference angle of 60 degrees? So we'll put 60 here, then I have 30. This reference angle is right here, so this is the 30. Remember, the reference angle is the angle between the terminal arm that's rotating and the x-axis. Reference angle is 60 here, so this angle is 30. Reference angle is 60, so this angle is 30. And these ordered pairs here, x is 1, y is 0. X is 0, y is 1. X is negative 1, y is 0. And right here, x is 0, y is negative 1. And remember, this is the unit circle whose radius is 1. So from here to here is 1 unit. And the radius of the circle is 1, and the hypotenuse of this triangle is 1. And that's true for all of these triangles. And opposite 30, we have a half. Opposite 60 is root 3 over 2. So the coordinates of this point, x is a half, y is root 3 over 2. So these are the same because the same reference angle. So this is a half, but it's negative, and the y is positive, root 3 over 2. So this one is negative 1/2 root 3 over 2. And this one is x is negative a half, y is negative root 3 over 2 because it's going down. And this one right here, x is a half, and y is negative root 3 over 2, again because it's going down. And you notice for the reference angle of 60, all the x's are a half except plus minus, and all the y's are root 3 over 2 because of the opposite to, that's the y, which is opposite to 60. And again notice that when there's a 30-degree angle, you have root 3 over 2.5. When you have a reference angle of 60, you have a half root 3 over 2. So I'm going to use those values to put them all on one graph. So here I go. Again, we have a unit circle whose radius is 1, so this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And this is 0 degrees, this is 90 degrees, this is 180, this is 270, and this is 0 starting off, or 360 if you make one complete revolution. 0 starting off, and notice this is positive going counterclockwise. And if we put all those points in here, if you can, I'll go back and show you with the 30. Here I go show you with the 30. Notice I have root 3 over 2 and 1/2. So root 3 over 2, root 3 over 2 and 1/2. Because this is a 30-degree rotation. And this one is root 2 over 2, root 2 over 2, and that's a 45 rotation. And notice this one is 1/2 root 3 over 2. So, and the 30, if you look at the triangle, this is 30, is a, if you make, I'll just do one triangle here, like this, and you make a right angle. So this is a 30-degree angle. So this is 1/2, this is root 3 over 2. So as the rotation goes up on the circle, notice that the y is 1/2 here. In the next triangle, the y is going to be more. So root 2 over 2 is larger than 1/2. In the third triangle, the y is higher again. So root 3 over 2 is greater than root 2 over 2 and 1/2. And notice as you go up, the y is getting higher, bigger, and the x, as you move, notice the x is going this way. If you draw this triangle, the x is getting smaller. So this is root 3 over 2, this is root 2 over 2, this is 1/2. So, and when you go all the way up, the y becomes 1 up here, and the x becomes 0. So notice it's changing. And this point here is opposite, so that's a negative 1/2 and root 3 over 2. This point here is root 2 over 2, root 2 over 2, same as these two, only the x is negative and the y is positive. And this one here is root 3 over 2.5, and the x is negative and the y is positive. And we're rotating around the circle, and when we get to here, we have, notice now I can come down here, the x is negative root 3 over 2, and the y is negative 1/2. And this one is right here, same values, root 2 over 2, root 2 over 2, but the x is negative and the y is negative. And this one, we have, same as here, so the x is the same, so we have a negative 1/2, and the y is root 3 over 2, like this one, but is negative. So in this quadrant, both x's and y's are negative. And as you keep rotating, again, this one right here, if you rotate across here, the x stays the same and the y stays the same. The only difference, on this side the x is negative, on this side the x is positive, but the y is negative down here and is negative here. This one is root 2 over 2, this one is root 2 over 2, and the x is positive and the y is negative. So again, if we look at it from this point of view, the x is the same, but the y is plus, the y is minus. If we look at it from this one, the x is negative here, the x is positive here, and the y's stay the same. And one more, we have x is negative, root 3 over 2, and the y is negative, because the x is positive. So we take this point, the x values are the same, but the y values are opposite of each other. So, if you have that circle, I draw the circles all the time when I'm working out questions and put in one triangle at a time. Let's look at it from another point of view. Exact values are 1/2 root 2 over 2 and root 3 over 2. You take your calculator, and a half becomes decimal 5. Root 2 over 2 with a calculator becomes decimal 7071, or rounded off to 0.7. root 2 over 2 becomes decimal 87, or you could call it decimal 9. So if you look at it, changing all, what I'm going to do now is use this and change all of these numbers so you can see what's happening. Again, let's put in these 1, 0, 0, 1, negative 1, 0, and 0, negative 1. That's a 0, 90, 180, 270, and you rotate all the way around from here right to here is 360. So if you think about it, let's put this on the inside. Root 3 over 2 is 0.87, and a half is 0.5. And right here, root 2 over 2 is 0.7. So root 2 over 2 is 0.7, 0.7. And 1/2 is 0.5. Root 3 over 2 is 0.87. And if we go over here, then we can put this one in. What happens? The x is negative 0.5 and the y is 0.87. And this is right here. The x is a negative 0.7 and the y is just 0.7. When you move over here, the x changes but the y doesn't. When you move here, the x changes to a negative 0.87 and the y is positive 0.5. And if you keep going down to here, again, whatever this one is, the x stays the same, 0.87, and the y is 0.5 but is negative. And this one is root 2 over 2, both negative, so it's a negative 0.7 and a negative 0.7. And this one is a negative 1/2, so it's a negative 0.5. And root 3 over 2 is negative 0.87. And we go over here and we get the x, that's a negative 0.5, so this is a positive 0.5, but the y stays. Now you might say, well, what am I putting these in for? And again, that's x is root 2 over 2, so it's 0.7, and the y is negative, so it's a negative 0.7. Because they're both root 2 over 2's. And the last one to change to a decimal, root 3 over 2 is 0.87, and the y is negative 1/2, so it's a negative 0.5. Now the reason I put all these decimals in is to show you that as you rotate around this circle, what happens, notice the x values are right here. The x is 0.87, and then the x becomes 0.7, then the x becomes 0.5, and then the x becomes 0. So as you rotate around here, the x is getting closer and closer to 0 when you do your rotation. And notice the y is 0.5, the y is 0.7, the y is 0.87, and the y is 1. So the y's are going up in value and the x are decreasing. And that's happening here. So notice the x is now on this side, so the x is negative, and the y is coming down. And the x is coming down to negative 0.7, negative 0.87, so the x is getting closer to the negative 1. As you rotate around here, the x is moving out towards the negative 1, and the y's are coming down, going towards 0. And that, as you can see, it's changing. So look at it closely, you see it. Now, why I did that, because I want to draw, allow me, I'm going to draw, I have to move my paper. Okay, make sure I got it right so you can see it. Let's see, that's okay. Okay, I have it. So what I wanted to do is look at the graph of cos theta. And cos is in terms of the x. So a lot of teachers will put y equals cos theta, but technically speaking, it's the x. So it's the x in terms of cos. This is theta, and this is the x value. So also remember that cos and sine are the x and the y. So when you think about it, the cos is related to the x value on the graphs. So let's graph. So if we start here at 0, this is 0 now, 0, 0. So we start with the cos is the x. So the x is 1. So when 0 degree, you have a 1. When you go to, this is going to 30 degrees, so the x is 0.87. So there's 30, because that's 90, 60, and I got it all in 30 degrees. So 0.87 is, there's 0.75, so let's just take a rough estimate. And the next one is 0.7, so there's 60, which is 0.7. So let's say it's about right there. Don't have to be exact. And a 90, when we have a 30, 60. Now, let's see, 0.87, and a 90 is a 0. So there's the 30, there's the 6, there's the 0 at 1. There's the 30 at 0.87. There's a 60 at 60, 30. Oh, I forgot the 45. I got 30. I don't have the 45 here. I just got the 30 and the 60. This is 0. This is 30, and this is 60. I don't have the 45 in here. And the 90 is x is 0. And as you go over here, you go to the next one, you have negative 0.5, which is right here. That's 120. Then you go to, I'm leaving off the 45, negative 0.87. So there it is right here, roughly. And a 180 is x is negative 1, which is right here. Then x is the negative. Remember, I'm doing the x, which is, this is the x on the outside, the y is on the inside. Negative 0.87 right here. Leaving off the 45, negative 0.5, which is right here. And 270 is a 0. And then we get 0.5. So that's 120, 150, 180, 210, 240. This is 300. So 300 is 0.5. And we go up to here. Then we leaving out the 45 is 0.87 right here. And we get back to 0. 360 is a 0. So notice the cos graph is looping like this. And the reason I took all the time to show you this, because it's important to see the shape of the cos graph. Notice it's looping, and notice if we leave here, the x is getting smaller and smaller going towards 0, and the y is getting larger going up to 1. So the x is getting smaller, and so notice the x is getting smaller and the y is getting larger. But we're not doing the y. We're only doing cos theta. We're only dealing with the x. We're not dealing with the y, because this is cos. Cos is with the x. So we're looking at the x values are large, and it's going down to 0. Then the negative is going down, so you can see it going down. like that. And then the x starts to go up again. It's going up. And then, as you get here, the x is going 0.5, 0.87. So that's the cos graph. And let's look at what the sine is doing. The sine graph, y equals sine theta. And again, we're dealing with the y is the sine. So the sine is in terms of the y values. The y is in terms of the y values. And what I want to show you before I forget it, what about if we look at a calculator? So I have a graphing calculator here. A graphing calculator. Okay, leave it right there. So I'm going to turn my graphing calculator on, clear that, and in my graphing calculator I have cos x. I could have cos theta, the x is in the place, same thing as theta. And my window is in my graph, my x value is going from 0 to 360. I got increments of 30 degrees, similar to the graph I got here. My y values are going from -2 to a 2, and the y values are -1. I'm going to hit the graph now. Watch. So notice these are increments of 30 degrees. That's a 90, that's a 0, and that's the 180 right there, down to -1. That's the 270 back to 0, and that's the 360 back up to 1 again. So what you see on this graph is the same when I move my sheet of paper. Compare them. There they are. They're being compared. Only I have it. I have the graph at a proportion here because I got one. One is this distance from here to here, whereas this degree is only a small distance. That's why you see it like it is. I just wanted to show you that on my graphing calculator. Now, it's important that you know, and let's do the sine now. So sine is the y. Sine is the y. So the y is starting off, the y value starts off at 0. 0 degrees gives you 0. Then the y goes to 0.5. I'm not doing a 45. Then the y goes to 0.87. And at 90, the y is 1. And then am I looking at the y again? Now the y is 0.87 for 120 right here. Then again, this is the 45. Then the y is 0.5. The y is the second one. So we're back to 0.5 right there. And the y is down to 0 again, right there. At 180, y is 0. And notice now, it's coming, the y is -0.5 right there. Then the y is -0.85 right here. And the y is -1 at 270. Then the y starts to go up, -0.87. And 45 is not there, 0.5 negative. And then back to 360 degrees, the y is 0. And you can see, now I'm going to show you, I'm going to trace this out. Notice, goes up, it comes down, loops, there it is, the rough estimation. But, excuse me, let's look at my graph. Let's move this up a bit and look at the graph on both of these. So now I have to go in, turn on my calculator again, and I'm going to change the equation. So I'm going to put sine x, same as the theta, and hit my, and again note, same shape, it goes up, and here's the pen, 0, sine of 0 is 0, the sine of 90 is 1, sine of 270 is 0, the sine of 270 is negative 1, the sine of 360 is 0. So it's the same shape. Just wanted to show you it on a graphing calculator what it looks like. No, I want to look at these again. Very important, very important, very important to see that the cos graph, notice the cos graph is related to the x. So I have an x here. This is sine is related to the y. Notice that the cos graph, watch, the cos graph is a, cos has the letter C, but the graph is, the graph of the cos is like this. And I always relate, that's a sideways C. That's the C going sideways. If you could take it and twist it around and look at it like that, you could see a sideways C. So when I think of cos, I think a C shape going sideways. Notice the sine graph. The sine graph, sine begins with an S, but the graph of the sine is this shape, which is a sideways S. So this is an S going sideways. So instead of an S, there's the sine on the, there's the S on the sine, the word sine, but the graph is a sideways S. So if I turn it sideways, there's the sideways S. Or if I turn it this way, there's the sideways S. Just wanted to show you that. So the graph of a sine is a sideways S. The graph of a cos is a sideways C. Notice the sine graph starts at 0 and it goes up and down. And notice every time you move through a 90, you get 0, 1, back to 0, down to negative 1, back to 0. The cos starts off at 1 and it goes down to 0, then it goes on down to negative 1, back to 0, back up to 1. So you have to memorize what the graphs are doing and learn them. Now let's look at, notice I have more here. So let's look at x equals cos theta. Remember, a cos graph is a sideways C. So a cos graph is going to look like this. But that's when you look at from 0 to 360. So if you look at, I always draw this figure here. This is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. The radius of this circle is 1. It's a unit circle. So I have a grid drawn here. This is theta, and this is x. So if this is the cos graph, the cos of 0 degrees is 1. So there's 0 degrees, cos is 1. And this is 90 degrees, the cos is the x is 0. So there's the 90. And 180, cos is negative 1. There's 180, negative 1. And this is 270, cos is 0, back to 0. And when we get to 360, we're back to 1 again. So this is like what they call one period. It's part of the cycle in a cos graph. Notice the cos is a sideways S. From 0 to 360, there's one of these waves if you want to. And if you go more, so the cos graph starts off, so if you plug 360 in your calculator, you get a 1. If you plug this in, which is 450 in your calculator, you'll get a 0. So it's a 1, a 0, -1, 0, 1. So we have another one. And if you go again, these are 90s now. So that's a 1 is coming down to 0, going down to -1, going up to 0, going back to 1. And there's another graph. So this is made up of 1, 2, 3. Happens 3 times. And if you go back to here, so if you think about it, look here. If you're going back this way, then it's back to 0 down to -1, 0, 1. So if we're going this way, it's 0, -1, 0, 1. So it's the same pattern, only this is -90. And the -90 is right here, and it's a 0. There's the -180, which is -1. And there's the -270, which is 0. And there's the -360, which is 1. So you go 0, -1, 0, 1. And so there's, and this keeps on going, and this starts to go down here. I put the arrow on it. That keeps on going. So, is the graph periodic? Yes, it repeats. The graph repeats every 360 degrees. Every 360, it starts over and makes the sideways C again. So 360, sideways C. 360 more, sideways C. 360 more, sideways C. So the period of the cos theta is 360 degrees. Every 360, it does one cycle. And the domain are the values of theta, so that theta belongs to the real numbers. Or we can call it R for real. Notice the maximum value for cos is 1. The minimum value is -1. So the range is between -1 less than or equal to, and it's cos theta less than or equal to 1. So it's the smallest value is -1 going up to 1. The values for cos are equal to -1, equal to 1, and all the values between these two. And note the graph of cos theta is a sideways C. Sideways C. And it's like this. That's how I remember it. Okay. Very important to understand. And we have sine. So this is y equals sine theta. And again, this circle, memorize it. It has 1, 0, 0, 1, -1, 0, and 0, -1. So this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And back to 360. Or we can go this way and do the negatives. But at 0, sine is related to the y. And sine is related to the y values. And sine is an S. So the graph is a sideways S. So it's up, down, and back to the middle. So 0, 1, 0, -1, 0. So a sideways S. So if you think of it that way, everything will go much better. Sideways S. So here the sine of 0 is the y, which is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is negative 1. The sine of 360 is 1. So it goes 0, up to 1, down to 0, down to negative 1, up to 0. And then it starts all over again. 1, 0, negative 1, 0. A sideways S. And if you're going back this way, you've got to come on down to negative 1, back to 0, up to 1, back to 0. And this is 0, and it can't go up. It got to go down to negative 1, back to 0, up to 1, and 0. So there it is. Very important to see this, how the sine graph is doing. Again, the sine begins with S, so it's a sideways S. Is the graph periodic? Yes, it repeats itself. It repeats itself every 360 degrees. 360, 360, 360. Or you can go negative 360, negative 360. The period of the sine theta is 360 degrees. The domain is theta belongs to the real numbers. The maximum is 1. The minimum is negative 1. The range is between negative 1, less than or equal to, less than or equal to. Notice I got negative 1 is on the left, 1 is on the right, and it's less than sine theta. And note that the graph of sine theta is a sideways S. So it goes, starts at 0, goes up to 1, back to 0, back to the bottom, and back to 0. So it hits a 0 3 times. It's the 1 once, negative 1 once. And just to summarize again, 1, 0, 0, 1, negative 1, 0, 0, negative 1, and the radius of this circle is 1. And the center is 0, 0. So if this is x and this is the cos graph, the cos of 0 is 1, then it goes down to 90, down to 180, up to 0, back to 1. So once it starts here, wherever it is, it'll go to a 0. So there it is. And if you're going over here, 1, 0, negative 1, 0, 1. Oh, let's see. Oh, make it a loop. Now it's 0. It has to go up to 1. And it's a sideways. So what about the graph? So this is x equals cos theta. What about y equals sine theta? So the y is, the sine is the y. So the y at 0, so the sine of 0 is 0. The sine of 90 is 1. So it goes 0, up to 1, back to 0, back to negative 1, back to 0. So there's the sine. And if we leave here, S of 0 goes to negative 1, back to 0, up to 1, down to 0. And again, you can see it's a and hopefully you can see that a cos graph is a sideways. Cos is C, so it's a sideways C. Sine is S, so it's a sideways S. And that brings us to the end of the video. Very important, very, very important to understand what the sine and the cos graph is doing. Very important, because the better you understand that in terms of the graphs, the better we're going to be able to solve equations, the better we're going to do sinusoidal functions. So And if you like my video, click the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.